This is Mia Muller and Samuel Hall calculating delta G at non-standard conditions.
The equation we are working with is ammonium nitrate solid plus water liquid yields ammonium ion aqueous plus nitrate ion aqueous. Our concentrations are 2 molar for ammonium, 3 molar for nitrate, and 5 molar for ammonium nitrate, all at 30 degrees Celsius or 303 Kelvin. Find this by adding 273 Kelvin plus 30 degrees Celsius. This equation is at non-standard conditions. If it were at standard conditions, it would be 1 molar concentrations all the way down at 25 degrees Celsius or 298 Kelvin. Now, since it is at non-standard conditions, we have to utilize the Gibbs equation, which yields delta G at non-standard conditions equals delta G at standard conditions plus R, gas constant, times temperature in kelvins times natural log of Q, reaction quotient. Now, first we're going to find our delta G at standard conditions for our products, and then we're going to find it for our reactants. Now, looking at our products, we've got negative 79.31 kilojoules per mole as a delta G at standard conditions for our ammonium. Add the delta G at standard conditions for our nitrate, which is negative 110.2 kilojoules per mole, and you get negative 189.51 kilojoules per mole. Now, you have to find the delta G at standard for our reactants, right over here. The delta G at standard for our ammonium nitrate is negative 183.9 kilojoules per mole, and you add the delta G at standard for our water, which is negative 237.1 kilojoules per mole, and that equals negative 421.0 kilojoules per mole. Now we are subtracting the delta G at standard of our reactants from the delta G at standard from our products. Subtracting a negative from a negative, this negative becomes a positive, and you get positive 231.49 kilojoules per mole for the total delta G at standard conditions for our reaction. Moving on to our reaction quotient. Reaction quotient equation equals the concentration of our products over the concentration of our reactants. Looking at our reaction, we see we have a solid and a liquid as our reactants. Solids and liquids are not ever included in the reaction quotient equation, so that makes it easy for us, giving us a concentration of 1 for our reactants. Looking over here, we see that we have a 2 molar concentration for ammonium, and we have a 3 molar concentration for nitrate. This gives us a Q, or reaction quotient, of 6. Okay, so we are getting what we need for our equation. R, the gas constant, is 8.314 joules per mole Kelvin, and we found our temperature 303 Kelvin. Plug all these pieces of information into our delta G equation, and we get delta G at non-standard conditions equals our delta G at standard conditions for our reaction plus the product of the R constant times our temperature in Kelvin times the natural log of our reaction quotient, Q, divided by 1,000 joules. The reason we divide by 1,000 joules is because we have a joules here and a kilojoules here. We want to maintain the same units, so you multiply by 1 kilojoule divided by 1,000 joules to convert this to kilojoules. Now we cancel out our units, and we get 236 kilojoules per mole. We keep kilojoules instead of joules because we're working with a delta G unit here. Now, this equation generally is spontaneous, meaning it has a negative G at standard conditions, but at non-standard conditions it has a positive delta G, meaning it is not spontaneous.